Hello, students. Welcome to today's session. Today, we'll be discussing principles of object oriented programming. So, broadly speaking, there are four principles, namely abstraction, encapsulation, inheritance, and polymorphism. Starting with abstraction. Abstraction means representing the essential features and hiding the details. Okay, so this is the definition. There are two parts: representing and hiding. Okay, in abstraction there are two parts. One is representing and the other one is hiding, or I can say showing and hiding. Okay, you are showing something and you are hiding something. That is known as abstraction. So abstraction means incomplete. Okay, in simple words, abstraction means incomplete. Now let's understand this with a few practical examples. The first example, let's consider the case of ATM. When you go to an ATM machine for withdrawing money, you put in your ATM card and you enter the pin, and you are presented with a screen which allows you to enter the amount and other options. So there you can see that in the ATM you have an interface. Okay, the interface consists of a few keys, right, and a screen and a place to insert your ATM card. That is the interface between you and the banking system. You are allowed to press the keys, use the card slot. Okay, so you know how to insert the card, how to press the keys, but you do not know how the ATM is working internally. Okay, you are just aware of the interface. That is known as abstraction. Means an incomplete information is given to you regarding as to how ATM machine operates. You only know how to use it, but you don't know its inner working. Okay, that is one level of abstraction, you as a customer of the bank. Okay, now there can be different levels of abstraction depending upon the kind of user. Okay, you as a customer are only required to know how to operate the ATM machine. Okay, to get the services of the bank. Okay, internal working is not required for you. But let's take another user. Okay, a technician user. Okay, you are the customer user, and now I'm talking about another user of technician type. Okay, so if anything goes wrong with the ATM, a technician will come and repair the ATM, isn't it? But for that, the technician must be having the knowledge of inner working of the ATM. Then only the technician can fix it. Otherwise, the technician won't be able to fix the problem. So technician's level of abstraction is different from your level of abstraction. This is what is meant by different level of abstraction for the same object. Okay, we are just talking about the ATM here, but the level of abstractions is different depending upon the kind of user. Okay, let's take another example, a car. Okay, a car. So in a car you have, it's, you know, it's a very complex mechanism, but you are not required to know that complex mechanism. You are just presented with an interface, the interface is what? It's mainly the steering wheel, the gearbox, then accelerator, brake, clutch. Okay, so you must only know how to use this interface. Okay, and you can drive the car. The inner working of the car, like how the petrol is injected or how the fuel is injected into the engine, and how the combustion is taking place, and how that combustion is rotating the engine, and how that rotation of the engine is converted into rotation of wheels, that you don't know how it's happening. Okay, or rather you don't need to know how it's happening. So this is another example of abstraction. Let's take the third example. All of you must be using Campus Care app. Okay, in that app you are allowed to view only the students section, isn't it? You can access the homeworks given by the teachers, but you cannot access certain areas in that program or in that application. Okay, for example, you cannot access employee record, or you cannot access any data related with management. Okay, it is there in the system, but you cannot view it, you cannot access it. That this is third example of abstraction. So remember, abstraction has got two parts. One is showing essential features, and the other one is hiding essential features. So this abstraction is achieved by data hiding, okay, or information hiding. Now what is this data hiding? When you see the code, when you practically see abstraction in Java code, you'll be able to understand the meaning of this data hiding. And this data hiding is implemented through access specifiers. Okay, I'll be showing you what is an access specifier in the later slides, but for now I hope that abstraction is clear. Okay, the next topic is encapsulation, or the next principle of OOP is encapsulation. So in simple terms, what is the meaning of encapsulation? Encapsulate. Okay, what is the meaning? Suppose you if you take a capsule medicine, okay, the actual medicine is encapsulated in a capsule, isn't it? That's an example of encapsulation. Okay, similarly in Java there is something called class. Okay, and this class has got two things. One is data and the other one is function. Okay, so function is the part of the class which operates upon the data. Okay, function is the part of the class which operates upon the data. So function and data, they are encapsulated in a class. This is known as encapsulation. Okay, now why is this needed? Why is encapsulation needed? So as to prevent unauthorized access of data. As we saw in the earlier example when I was discussing abstraction, you saw that you're able to access the homeworks given by the teachers, but you aren't able to access the employee record. Okay, so that is known as preventing any unauthorized access or misuse. Okay, and that is achieved through abstraction. Okay, now you might be a bit confused that what is the difference between abstraction and encapsulation. So let me tell you that abstraction is implemented through encapsulation. Okay, I repeat, abstraction is implemented through encapsulation. Okay, so what is the meaning of this? So that point I'll be showing you an actual Java code, and I'll be explaining abstraction and encapsulation and how they are related. Okay, so if you don't understand or if you're a bit confused now, don't worry, you'll be the point will be clear in the next few slides. So let's see what's written here. Access to the data and code inside a class is strictly controlled. Okay, that means the data is not available to the outside objects, to other objects. Okay, objects belonging to another class, they cannot directly access the data. They have to go through the function. If they want to access the data, they have to go through the function. Okay, and only this function will be able to change the data present here. Okay, outside functions or a function belonging to a different class cannot access this data here. Okay, so this is known as encapsulation. Now I told you that there is a relation between abstraction and encapsulation. Okay, abstraction, you can think of it like this: abstraction is implemented through encapsulation. Okay, so encapsulation means data hiding plus abstraction. Okay, data hiding plus abstraction. So what is data hiding? Data hiding means, you know, that data hiding is the part of abstraction. As I discussed earlier, you are hiding something and you are showing something, isn't it? So hiding part and showing part, right? So let's see a practical code. Okay, so this is a class. Okay, it's a class and its name is student. So the name of the class is student. Okay, and I have declared a few variables here. Okay, a few data that is related to the student class. So like name, address, age and gender, these are the kind of data associated with the student class. Okay, or student object. Fine. So, and the next thing is the functions. Okay, these are the functions. I've just written the prototype. Okay, to keep things simple. Okay, because I did not want to complicate it. Okay, that's why I put it in the form of prototype. Okay, the internal code is not necessary. Okay, so there is this function set name. So there is this function set name, set address, set age and get name. Okay, set name is for storing something into this variable name. Okay, set address will store something in the address. Set age will store some number in the age variable. Similarly, I've got get name. Okay, so get name function will be used for reading from the variable name. Okay, so these variables are protected from from any unauthorized access. And how is that being achieved? That is being achieved through this keyword private. Okay, it is being achieved through the keyword private. Private, you know, private is an access specifier. Don't worry, okay, I'll not explain it in detail now, but for now it is sufficient for you to just know the technical term. It's known as access specifier. So public and private both are access specifiers. Okay, the meaning of private is that all these variables here, okay, they are only accessible within the class, they are not accessible outside the class. Okay, so any object, okay, any different object which wants to access this set of data, okay, this set of data, any object, if it wants to access, it has to go through the functions here. Okay, so the object will access the data through these functions. Okay, and notice that these functions, their access specifier has been set as public. That means outside the class it can be accessed. Okay, so from outside the class, if any object wants to access the data here, they have to come through this proper channel, and that proper channel is these functions. Okay, now if you correlate this with the ATM example, okay, so this is your interface part. Okay, this is your interface part, because this is what is visible, this is what is visible to other objects. Just as how the ATM's key, screen and the card insertion part was visible to you, isn't it? Similarly here also this part is visible to other objects. Okay, but this part is hidden, this part is hidden. So this can be compared to the working of the inner working of the ATM machine. Okay, so this part is the hiding part, and this part is the showing part, isn't it? This one is hidden and this one is shown. Okay, now if you combine both of them, that means this is abstraction, right? Remember, recall the definition of abstraction. Abstraction is representing the essential features and hiding the details. Okay, abstraction means hiding the details and showing only the essential features. So this part here, this is what, this is abstraction. Okay, abstraction is happening through data hiding plus showing the essential features, right? Now if you put this whole thing, inside a class, okay, inside a class, this is known as encapsulation. You are encapsulating the whole mechanism into a class. Okay, this is known as encapsulation. So I hope it's clear that how encapsulation and abstraction are related. Okay, so we'll stop here, and in the next video I'll be discussing the remaining topics or the remaining principles: inheritance and polymorphism. So if you do not understand, if you have any doubt, go through this video multiple times. Okay, it will surely become clear to you. Okay, Okay, so let's stop here. Thank you.